I need you to write a list of all the lists you'll take with you when you go shopping. There is a grocery list, a clothing list, a bookstore list, a sports store list, a craft list. Are you writing this down?
Sometimes you have a list of lists, or you have a list of x and y coordinates. X and y coordinates are a great example of a good use of a tuple, because we would just want our x and our y. We're not going to add more dimensions as we do our graphing. So if we want a list of x and y coordinates, we could say cores equals, and then our list where we would have like 1, 2, 2, 4, and 0, 0. Pretty easy, right? Here we've nested tuples inside a list. You could also nest lists inside a tuple. And if we want to add to the first or the second list, we can. And you might be thinking that we're not allowed to because tuples are immutable. But remember, all we're storing in the first and second components of this tuple is the reference to these lists. So we can add to the house without changing the house address, which is all the tuple is storing. We just can't add another list to the tuple, but we can change the lists included as much as we'd like. You can have a list of lists, like you could have a list that has a sublist called pear, apple, orange, another one that has tomato, cucumber, olive. And then if you want to iterate through every item in those lists, you could say for items in list, colon, and then for item in items, colon, and then we could say print by, comma, item. So actually nesting data structures and nesting loops go pretty hand in hand, or loop and loop, or list and list. Sorry, I should stop.